to all the organizers and the panelists for coming together on such a important discussion. So here, my objective is to, put together the challenges that India is facing, and many of these challenges can be can look like huge, overwhelming, depressing. When I put the numbers, in fact, I work as a climate scientist here, and I've been working on these numbers for quite a long time. And whenever I see the numbers, it can be depressing. But I try to view it as in a clinical way, and also try to look into solutions. So here in this talk, I'm not running into solutions, but identifying these challenges and also looking at the numbers and the extent and the area and the magnanimity of these extreme weather events due to climate change. They give us an idea on how to face them. And there are occasions when many of these extremes work together. We call them compound events. So let's take a ride through the climate challenges or vulnerabilities that India is already facing due to that 1 degree Celsius change that has happened since the pre-industrial time. So here, this image here looks a bit alarming. It shows far away the hills are there. In one side, the sea is there, and everything is changing. The atmosphere is changing, the hills are changing, the sea is changing, and the city is facing a dark scenario. And if you look at India as a whole, you can see a small map of India here. We have to the north, we have the Himalayas. In fact, over the Western Ghats also, we have the hills and mountains. And on all 3 sides, we have the Indian Ocean covering all 3 sides, right? And all these elements, the mountains and the oceans are changing, and at a rapid pace. In fact, our research shows that, and this is what has been identified by the recent IPCC climate report as well. Indian Ocean is the fastest warming ocean among all other tropical oceans. Yeah. So, and in fact, by climatologically itself, Indian Ocean is the warmest waters. So the warmest waters are warming at the fastest rate. And we know that through climate change is the oceans that are absorbing most of this heat. So the previous speakers, Professor Malik talked about, Malik and Ravi Pandit talked about how much ppm of carbon dioxide has been going out and how many gigatons, right? So it's absorbing all the solar energy, and 93% of this additional heat from global warming is going to the oceans. And we see a response of that over India, the Indian subcontinent, which is covered on 3 sides by the Indian Ocean. And the Himalayas are also facing rapid change. The glaciers are melting. So let us look into some of these changes that we are facing in this region. Much of these extreme weather events due to climate change are similar for the South Asian region or the Indian Ocean region that I call. So one of the set of extremes are the monsoon-related extremes. Now, I will go into some of these extremes one by one in my talk. And definitely across South Asia, the floods have increased, rapid increase. In fact, over the Indian subcontinent, there is a 3-fold rise in widespread extreme rainfall events causing floods. And this has been a consistent phenomena, rising phenomena for the last several decades since the 1950s. And there is also, at the same time, when the heavy rainfall events are increasing, the total amount of rainfall that we receive during the monsoon season, the total amount of rainfall, that is decreasing at a gradual pace over some regions like the Central India and North India and some parts of Western Ghats. So this leads to frequent droughts as well. And we can see similar events happening over some other regions as well. And associated with these changes, there are other changes in biodiversity. We saw locust swarms happening over Africa, which in fact got carried over the monsoon winds, the winds and the moisture-laden winds to Arabian Peninsula, to Indo-Pak region, and ultimately reaching the Indian continent as well. So these elements of climate change are interacting in multiple different ways, in ways we don't even imagine, and reaching us on our doorsteps, affecting our water security, our food security, energy security, and all. And then we have one of my favorite topics is cyclones. In fact, just 1 hour back, one of my PhD students defended his work on cyclones and in a rapidly changing Indian Ocean. So we show that the cyclones are changing over the North Indian Ocean, and the way they are approaching India is also changing. And cyclones release these storm surges or huge waves which splash on our coastline and impact the coastal zone. So, and we know the other impacts due to cyclones. Cyclones are now bringing more rains than ever. That is another impact. And we also have heat waves, mostly towards the Indo-Pak region, northwestern region, and encroaching to some parts of India. Terrestrial heat waves. Now, like terrestrial heat waves, there are heat waves in the ocean also. In fact, if you just Google marine heat waves over the Indian Ocean, you can see some of the recent studies from our group. First comprehensive study looking into heat waves in the Indian Ocean. Now, we have heard about terrestrial heat waves, but what about marine heat waves? These are also heat waves like land heat waves, but they are not just in the surface, they goes into the subsurface as well, results in coral bleaching, and also affects the marine biodiversity and marine ecosystem, and ultimately the fisheries also. Now, we don't know much about the impact on fisheries on our coastline. It has been shown that the marine heat waves impact fisheries in Korea and other regions. So we have a severe lack of data on how many of these extremes are interacting with our ecosystem and our food security as well. Now, there are other impacts also of a rapidly warming ocean. One is the declining marine phytoplankton. Now, marine phytoplankton are these microscopic plants which support the entire life. Even the oxygen that you breathe right now, 50% of that oxygen is from the marine phytoplankton, released by the marine phytoplankton several million years ago. And they form the base of the food chain, again coming back to the food security. So there are all these kind of impacts, and overarching impact there is the sea level rise. Now, sea level rise is rising across these regions, and particularly along our coastlines also. In fact, an island, a small island called Wan Island in southern Bay of Bengal near Gulf of Mannar, is vanishing. So that is the telltale sign of global warming and sea level rise, sinking our own regions, which are under the Indian territory. Now, parts of northern Bay of Bengal also have a drastically fast sea level rise, which could affect the food, water security, and even the health, because the hygiene over this region is dependent on the saltwater intrusion and many other factors. Now, I will get into one or two of these factors and how they work together, challenging the climate and the security over India. Now, one of the most interesting and challenging aspect or extreme weather event are the cyclones, obviously. And just last year, we had back-to-back cyclones just before the monsoon, right? And usually just before the monsoon onset, it is not a favorable condition for cyclones to form because the monsoon prevents the cyclone to form vertically. But we had these back-to-back cyclones that time. And one of the reasons is the additionally available heat and moisture from these oceans to support these huge systems. Cyclone Tote was an extremely severe cyclone of maximum intensity of 220 km/h. You can imagine the speed by comparing it with the speed at which you drive your car in the city, maybe 40 km/h, 60 km/h, or around that. So this is like huge. And we had on the East Coast also, we had a cyclone, Yash cyclone, 110 kilometer per hour. I'm comparing this because I have a short video in one of the slides where I show how these cyclones manifested in a different way, despite being of different intensities. Now, some of our studies shows that as the Arabian Sea warms, one of the fastest warming in the Indian Ocean is in the Arabian Sea. And this has gone up to 1.2 degrees Celsius to 1.4 degrees Celsius in the Arabian Sea. That is compared to a 0.9 to 1 degree Celsius global average temperature rise. So as the temperature rises in the Arabian Sea, the number and intensity of cyclones, and also the heavy rains also increase. Now, what is that number? Over the Arabian Sea, this is, there are two figures here, one on the left and one on the right. These are in different decades. The early decades from 1980s to 2000 shows a number of cyclones during the pre-monsoon and the post-monsoon. Similarly, the recent decades, recent 2 decades. So the last 4 decades, during the last 4 decades, we can see the Arabian Sea cyclones have increased by 52%. If you count the number of cyclones here in these previous decades and the recent decades, there is a 52% increase in the number of cyclones. Bay of Bengal has been steady, more or less steady. Generally, it used to have many number of cyclones, but there is an 8% decrease. But at the same time, there is a slight increase in the intensity of cyclones. Now, coming back to the Arabian Sea, there are more changes because of the rapid warming here. The number of, among these cyclones, the number of very severe cyclones have increased by 150%. And not only the number, the duration. So many of these cyclones are spending more time over the ocean than ever. So that means it can straddle the coast and move like Cyclone Tote, started from Lakshadweep to Kerala. It's touched all the states along the west coast before landfall over Gujarat, right? So this duration has increased by 80%. The intensity of cyclones also show an increase, significant increase, 20 to 40%. So this is all from the data from IMD and satellites, and all this data is on our face. And models also clearly show that this is due to the warming in the oceans, ultimately due to climate change. Now with cyclones, I told that we have huge waves and storm surges. These are the storm surges that happen during Cyclone Tote, just to have an idea. So generally, the winds cause waves of less than 1 meter or 1 meter height or so. But during cyclones, you can see the wave height goes up to 6 meters. So along the coast, this means a lot of water splashed over the coastline, flooding the region. You can see near Mumbai also. Now, some estimates at some locations, these are from buoys in the Arabian Sea. Now we need more observations. We don't have much of these buoys measuring data. That's one thing that deter from us from understanding the change and also make precautions to address these impacts. Yeah. So some buoys shows that there are waves up to the height of 9 or 10 meters. And just think of it happening over low-lying lands over Mumbai coast. I will show you a picture later, and you can think how it will be. So now coming to other extremes, I told that the extremes are increasing, and over India there is a threefold increase in widespread extremes causing floods. Now this, you can see a map of India, and the colors, the warm colors or the red or yellow orange colors shows the regions where the widespread extreme rains above 150 millimeter per day are increasing. And the blue colors show where it is decreasing, and neutral colors show not much change. And you can see across central India, and this is why like this. So this is that path of where the monsoon acts. So this is for June to September, where the southwest or the summer monsoon acts. You can see across the entire path of the monsoon, because monsoon is showing more fluctuations than ever, more variability. It is causing that short spells of heavy rains. So even though the total rains are decreasing, the total rains during the season are decreasing, there are occasions like a few days during the season when the atmosphere is full of water. And one of the important factor, this is the physics that we all should remember. Warmer air holds more moisture than cooler air. So warmer air holds more moisture and for a longer time. So it doesn't rain for a long time, but when it rains bountiful. So that is what you are seeing in most of these regions in central India, parts of Western Ghats. And you can see this part of Maharashtra close to Mumbai and where Mahabaleshwar and all that confluence is there. West Central in the Western Ghats region. This is where we had the recent heavy rains. Now, this is the data for the last 70 years from 1950 to 2020 and the change in extreme rainfall events. So this region specifically shows that rise in extreme weather events, and other parts of Western Ghats as well, from Kerala, some parts of central Kerala, parts of Karnataka, Maharashtra, Gujarat, central India, northeast India, including Assam, where again we see extreme rainfall events very often. So there are occasions when these events act together, like when cyclones bring more extreme rains because the atmosphere can hold more moisture than ever. Now, these short videos I'm showing between Cyclone Tote and Cyclone Yas. This was along the coast of Kerala. You can see that storm surges pushing water. And some regions, if it is a low-lying land, this can go into several kilometers. That's what you would see with Cyclone Yash. And occasionally, these cyclones will, you can see that it's all cloudy, right? So the cyclones bring heavy rains as well. So now this is on the Odisha coast, Cyclone Yash. If you remember the early picture, Cyclone Yash was half the intensity of Cyclone Tote, but the impacts were much more larger. And we thought the east coast of India was much prepared, but the impact due to climate change was much more large scale. That the loss was huge, the agriculture loss and property loss. And the reason is that many of those events compounded one on each other. So there was storm surge due to cyclones. Over that, we had the rainwater due to cyclones, added with the pinch of sea level rise due to climate change. And one of the reasons for me to particularly tell is that the North Bay of Bengal, that is one of the regions where the sea level rise is much more than the other regions. And unfortunately, the east coast of India was, at that time when the cyclone occurred, there was a high tide also. Now this is a natural event, but along with other events, it multiplied or aggravated the impact of this compound flood, and it went several kilometers ahead. So there are all these kind of overlapping events. Now, what is the problem that we face? We approach each event separately. There are scientists who study rains separately. There's scientists who study cyclones separately, and we have the statistics for each of them. There are people who study on sea level rise. That is a separate study, but we need to have an integrated approach. So we need to have data for that integrated approach. We need departments to work together, and we need forecasts also to have that integrated approach. Now, if that was a picture from the coastline, we have a picture from the interior Maharashtra also. Now, one fine day, we were amazed with this sudden spurt of heavy rains over Mahabaleshwar. So this is a part of Western Ghats in Maharashtra. And we have only scanty observations over these hilly regions. And one of our stations showed on 19th around 100 millimeter, 1 to 3 days, 100, 150. And then suddenly on 22nd July, 480 millimeters of rain. And 23rd July, 600 millimeters of rain. That is like in just 2 days, 22 and 23, more than 1,000 liters of rain per square meter. Yeah, that's a huge amount of rain for a all area. Other regions, I heard that Citizen Science Network and their stations showed much higher values for other regions. So these rains released a lot of water into these rivers, which flooded townships like Cyclones. It was all over the news. Now, what happened and how was this compounded? The sea level rise from the Arabian Sea, and again there was a high tide in the by the coast that resulted in a slow flushing out of this water. So the floods remain in this region for a longer time. Now, we are talking about climate change and all, and it's easy to blame on climate change for everything. Of course, heavy rains where there, sea level rise was there, but were there other factors also? Obviously, there are factors like how we use the land and how that interacts with the climate change elements. One is the river encroachment. This is just one of the examples where we squeeze the river and the river floods out. Here is a schematic of that. So which points out that the climate change is not the only culprit that we should see. We need to have an integrated approach on other direct human interventions also. So generally rivers meander, and when the rains happen, heavy rains happen, they have these floodplains, muddy swamps and floodplains and beaches where it can spread out and gradually sink in, absorb the water getting absorbed. But if that space is encroached and the meander is lost, then, and we build the houses around it, the rivers won't listen to you. When heavy rains happen, extreme heavy rains because of climate change, all the surrounding areas get flooded quite fast because there are no floodplains to sink. Yeah, so it is quite easy to blame, put the blame entirely on climate change, but in many cases that's not the only case. Yeah, we need to work on our local factors. So many times, though climate change is global, the impacts are always local, and some of the actions are also local. Some of the actions and solutions are also local in terms of adaptation, in terms of preparing the land and property. We need to disaster-proof our land, our rivers, and our public infrastructure for these changes that we are seeing. Again, another picture. Now, this is a famous picture from an aerial picture of Mumbai. You can see the haves and the have-nots. These blue colors look pretty, but these are tarpaulin roofs. They don't have proper roofs over here near the high-rise buildings. So when we have heavy rains and heavy rains from the top and flooding from the bottom, it can be due to the sea or due to the rains and due to the cyclones. We don't know if it is the roof that's getting thrown out first or if it is the floor getting washed out first, right? So it's a situation like that. And at the same time, we see how the city has changed. Can you spot a river here? We in fact had the Mithi River going in through the middle of, supposed to be in the middle of this picture. So that has been heavily encroached. It is less than a nala now, so it cannot take the additional water from the city. So now this is an example of Mumbai, but represents cities across the globe, not just India or South Asia. Yeah. So these are situations which we need to rethink. We might need to redesign our cities, to approach these situations. Yeah, and these are places where we used to have a lot of mangroves which could absorb the cyclones and the heavy rains. They are the lungs of the city. They are not existent anymore. So we can, I told you I'll be talking about challenges, but I cannot leave this stage without talking a bit of solutions, one or two solutions, and then I'm off. So the IPCC reports give some potential solutions or best practices as well. It shows how with the sea level rise and other coastal impacts we can approach it. So there are many solutions on protecting it or retreating from the coastline, but it always shows the ecosystem-based adaptation, probably a mix of ecosystem and artificial adaptation as the best choice for fighting climate change. And that is one point. And I have seen that a collective effort is required. Of course, we need innovation and all for mitigating climate change. At the same time, we need better observations. Like I told you the story of Mahabaleshwar, but there are many locations over the hills, and even within the cities, there is a large variability, spatial regional variability in terms of rainfall. So we need high resolution observations, and we need to work on improving these observations, forecast, and research at the same time. And we need to connect it with the local administration. We need to network between departments, because multiple extremes and ecosystems are working with each other. And there are occasions when national agencies like IMD and others cannot reach all these regions. That's where a collective effort from citizens can also help. I have been working with citizen science networks like Saturk in Maharashtra, and also the Municipal River campaign in Kerala. So these networks have helped a lot in installing rain cages and other river sensors, and also educating the public as well. So all these efforts, collective efforts together, can help us to look forward to a climate resilient future. And that's what I'm also looking forward to amidst all this potentially depressing news. And one more thing, the story doesn't end here. The changes that I showed, the pictures that I showed, are the resultant of a 1 degree Celsius change. Now, and I told you that over the Indian Ocean, it has gone up to 1.2, 1.4 degrees Celsius. Now, by 2050, this is going to be 2 degrees Celsius or 2.5 degrees Celsius. And by end of century, it will be 3.8 degrees Celsius. That's what our projections show. And if I give the example of Mumbai, yeah, if I give the example of Mumbai, the population of Mumbai is currently around 20 million. Yeah. So in 2020, 20 million. By 2050, it is projected to increase up to 40 million, maybe, potentially. And there are studies showing there is a lot of domestic migration, especially from other climate challenged regions like UP, Uttarakhand, the Himalayan foothills, where there are other kind of climate challenges. So people are, and the agriculture there are again facing these issues. So the people from there are migrating to the mega cities, which is facing a different kind of challenge. So these coastal cities are now seeing a huge population explosion, and with the future temperatures rising, future extremes increasing, if you are planning something for the future, if you are redesigning the cities for the future, we need to consider these challenges of the future, not just the past. We can't just think about floods in the past. We should think about floods in the future, the cyclones in the future, and also the population. You can imagine it will be a Mumbai on top of the current Mumbai, yeah, by 2050. So what do we do? If we make coastal highways or other infrastructure, it has to last the next 50 or 100 years, right? So we need to be futuristic. We need to disaster-proof this. So that is a message that I have. And thanks for this very stimulating discussion. And I'm happy